I guess we can start this interaction by just maybe possibly asking you a question that when someone says mechanical engineering, what comes to your mind? What is the the idea of mechanical engineering that students in general possess? And I think what we can do is then try to either reinforce that idea or try to debunk some myths about mechanical engineering.
So if the organizers can unmute students, like I think that would be
pretty cool.
So like students can raise hands and maybe the organizers can unmute them.
Or you can just write things in chat. That's also cool. Say a couple of comments here are Ferrari, building things, nuts and bolts, real vehicles, not EVs. Well, EVs are real vehicles. So, okay, automobiles, engines, aerospace falls in mechanical engineering. I think in the yesteryears it could happen, but I think aerospace has expanded enough that it kind of deserves a department of its own, which is here at IIT Bombay as well. There is enough overlap, and there are people who in mechanical engineering who work with folks in aerospace as well. And you'll see there are plenty of things we're doing here at mechanical engineering which are of use to ISRO as well. So yeah, dealing with machines, evergreen department, study a physical machine that person.
So I think still the most of the thinking which is coming around is like engines, traditional mechanical engineering, like engines, automobiles, machines, force, movement, nuts and bolts. But like I think as we will show you, like it is much broader than this.
Yeah.
So mechanical engineering overlaps with physics, it overlaps with chemistry these days, it overlaps with electrical engineering, it overlaps with civil engineering, it overlaps with the biology. And all of that is going on in our department here at IIT Bombay, and not just at IIT Bombay, like I'm sure at all IITs in mechanical engineering, it has become quite diverse now.
Yeah.
Computerized solution to problems. So that's true for every department, I guess.
Yeah, that's true for every department. But let's do one thing now. Let's show you, the research that is happening at IIT Bombay in mechanical engineering department, and then we'll try to expand on a few things as we go through. And after the video is over, we can start taking questions from students. So I'll request the moderators here to keep an eye on the chat and pick out any good questions that come across.
Okay, so we will share the screen now. So I hope you are able to see our screen. Can one of the moderator confirm like the screen is okay?
Yes, sir.
Voice is audible, right? Hello.
Just play the video once. Yeah, voice is audible.
There are some machines which use natural resources like fuels to produce power. There are some machines which use this power to produce other machines. There are machines which produce gadgets which we use in our everyday life. By creating, designing, manufacturing and operating various types of machines, Mechanical engineers, like all engineers, provide us good, comfortable life.
Mechanical engineers are expected to design power generation units such as automobile engines and turbines. And they are expected to design mechanisms that transfer the motion and the power from the place where it is generated to the place where it is needed. For example, in automobiles, from the engine to the wheels. They are also expected to manufacture these. So they are expected to design forging presses, other manufacturing process like casting for metals as well as plastics, because all types of materials are being used in engineering nowadays.
Increasingly so, mechanical engineers are having to deal with systems which typically are not considered under the purview of mechanical engineering. For example, today's automobiles utilize a huge amount of electronic controls, and the algorithms that run these controls are driven by understanding of the behavior of mechanical systems.
With technology advancing and integration of various engineering fields, mechanical engineers work with robotics and making devices at the micro and nano scales. These are so-called MEMS or micro electromechanical devices.
Mechanical engineers are increasingly getting into biomedical engineering, especially medical device innovation. In our lab, we get doctors from various hospitals who come to us with unmet clinical requirements. We put groups of researchers from multiple disciplines like mechanical, materials, electrical, electronics, computer science, software, industrial design to solve the problem. In the last 2 years, we have developed almost 140 different medical devices, filed about 25 patents, and about 9 or 10 of these are already in hospitals or in industrial practice through startups or entrepreneurs.
Mechanical engineers are working with complex biological systems such as biomechanics, bone replacements, blood flow, and effect of radiation on human tissues.
We in the Department of Mechanical Engineering have a group working on advanced manufacturing. As a part of that, we have a center known as National Center for Aerospace Innovation Research, working for developing aerospace technologies in the area of manufacturing. Currently, India is undergoing a phenomenal transformation. We feel that our technologies and our innovations will play a major role in developing the economy for the country.
The primary focus of our work is development of the next generation of propellants. We have chosen the cage hydrocarbon family from where we choose these compounds. They can serve as fuels, as oxidizers, as binders for solid propellants, any role. For fuels, we are trying to put them inside a gas liquid rocket chamber and burn them out so that we figure out what is the thrust, what is the specific impulse, and how good that propellant is.
Traditional topics of heat transfer and fluid flow are seeing investigation of complex flows in rarefied gases, visualization of flow using optical techniques, study of two-phase flow, and cooling in nuclear industry, as well as one of the most challenging heat evacuation problems of today, that is heat removal from computer chipsets. The quest to achieve lower and lower temperature leads mechanical engineers to the field of cryogenics that is extremely important in space and fusion-based applications. Machining is getting more and more complex, and engineers are working in precision and micro-manufacturing areas, as well as machining of complex alloys. Complex parts are being made using powder metallurgy and 3D printing. Finally, in the modern world, engineers are driven to develop and test newer materials with complex properties. And here, mechanical engineers work at the bridge between mechanical engineering, material science, and physics. We are still making machines, but they are getting more and more complex. We are still removing heat from devices, but these may be at the micro and nano scales. We are still reducing friction in fluids and in complex machine parts. And we are dealing with devices that were unthinkable even a decade ago. And all this to improve machine productivity as well as human productivity.
Okay, to supplement these thoughts, I think you have got a broad idea.
In the next 15 minutes and 58 seconds, I'm going to show you what a typical.
Okay, So I think you have got a broad idea of what mechanical engineering is all about, and it has grown from traditional mechanical engineering, like what all of you are thinking, actually, at least what we saw from the chats. So it has gone beyond its boundaries, like, and in fact, all the branches have gone beyond their boundaries. So mechanical engineers now interface with physics people. Let's say you pick a area of quantum computing. So all quantum computers, like to date, all of them work on cryogenics. So they need very, very low temperatures, sometimes of the order of millikelvin. So here we are talking very, very close to absolute zero temperature, like close to 100 millikelvin. And the way to reach is through cryogenics. So we use liquid helium to cool them. And there are additional mechanisms like mechanical mechanisms like which we use to cool to that low temperature. So mechanical engineering department at IIT Bombay, here we are taking the lead in the cryogenics. Like let's take another example. You have seen the MRI machines, like you have seen the 1 Tesla MRI machine, 2 Tesla MRI machine, 3 Tesla MRI machine. So how do you generate that much amount of magnetic field like for MRI machine? So for those, we need superconducting materials. We need to flow very large amount of current without any heat dissipation. You know this Joule heating, I square R. So that could completely destroy. If you flow a large amount of current, that could completely melt the system. But there are materials, superconducting materials, which physicists, mechanical engineers all are studying. And we are studying these materials at a low temperatures, like so that we are able to flow the current. Like we need a very, very large amount of current so that we could generate these large amount of fields. Nowadays, even at IIT Bombay, we are able to generate up to 14 Tesla, like routinely. And even if you go to bigger places, like they are able to generate up to like the national labs, they are able to generate up to 100 Tesla of fields. You could see, imagine like how large those solutions are. Same thing if we look at the overlap with the chemistry, like Professor Arindrajit Chaudhary mentioned about combustion, like all the fuels they're using to power the rockets of today. So they're analyzing their behavior, thrust, all these things. So again, there is overlap. And the biology aspect, like we are making a lot of biomechanical devices, like Professor B. Ravi mentioned, like how many patents and how many devices they have actually incorporated in the hospital. We have more faculties who are really working on human biomechanics, like in case, let's say you are playing, you injured your leg or hand, like how to fix them, what are the mechanics of that, what is the mechanics of fixing that, why did that particular injury occur, like can we prevent it? So all these questions are being routinely answered these days.
And not just so another aspect where biology comes in is there are people exploring blood flow through principles of fluid mechanics, and to kind of analyze how the blood vessels, how the blood is being carried in blood vessels, and all of that modeling. So this was something that was not. This is not in the purview of traditional mechanical engineering as we sort of think, and that's what we sort of saw when we asked you guys what you guys think mechanical engineering is, and pretty much everyone was talking about automobiles, mechanical, machines and mechanical devices. But that is a very traditional view of mechanical engineering. Mechanical engineering is not, I mean, we're still doing those things, but there is so much more that is being done, in the departments of today. I think there is no engineering in this day which can work in isolation. Various engineering departments, engineering sciences, they're working in collaboration and new things are coming up. And this is the only way you can expand the sphere of human knowledge.
So there are two more comments in the chat, like biomechatronics. Yes, indeed, our department is working towards that direction, and there are several faculties who are taking a lead in that. In mechanical engineering, we're taking, of course, people collaborate with the biology people, doctors outside, like real hospitals, like people have ongoing collaborations. So they do project with them so that the problems are as close to reality and their solutions are like as close to reality as possible.
Yeah.
The another is when someone is asking about this laptop liquid cooling. So of course, the laptops nowadays, like the cooling is through fans only, but there are devices like our server rooms where we need advanced cooling, or let's say a library. Like even if you pick IIT Bombay's library, there are designated cooling systems. So yes, mechanical engineers do design those cooling systems. And as we are going smaller and smaller scales, like really, like if you recent advances in the chips, if you see in the IBM has produced now 2 nanometer chip. So you could imagine the heat density which is generated, how to dissipate that heat. So we are able to study within our department, we are able to study such small length scales and such small time scales also. Like you have heard of millisecond, microsecond, nanosecond, picosecond, then femtosecond. In our department where there is research ongoing, like where people are actually studying at all those length scales and time scales to study this phenomena and get close to the reality of the problem and provide solutions. Like,
yeah.
And coming to EVs also, somebody was asking, yes, our department is taking a lead on the EVs also, and not just IIT Bombay. I'm talking about in general about all IITs in mechanical engineering. They're all taking the lead on EVs. Like, so of course, from thermal management point of view, battery, like storage material point of view. So all the angles, the chemistry point of view, all the angles being covered. And of course, not just the mechanical engineer participate in these projects, like entire ecosystem, like from the people from chemistry, metallurgy, people from physics, chemistry background, like all the people would participate in these studies and come up with a combined solution. That's has been an approach across all IITs. Like, so no department in today's date is independent, like they are just conducting independent research. It's all interdisciplinary research.
And I think at IIT Bombay, I mean, so both of us, when we were students respectively at IIT Delhi and IIT Kanpur, at that time, I think that the scope of collaboration between departments was not as intense as it is today. I mean, I think in this day and age, when students come into IIT Bombay, they have so much sort of awareness that they can get through, taking several electives, and I guess it's, sky's the limit at this point. If there's a particular application that you wish to work on, be it related to human body, be it related to anything else, you can acquire tools. And I think you should aspire to not just in the purview of mechanical engineering, but what other departments have to offer you. So moderators, at this point, we will ask you to pick out some questions from the students, which we could both try to answer to the best of our abilities.
All right. So one question has come up. What are the differences and similarities between aerospace and mechanical engineering?
Interesting. I think
so aerospace and mechanical, I think they are in terms of mechanics, like controls, there is a quite good amount of overlap. Now, even in the propulsion system, like mechanical engineers are studying the propulsion systems, aerospace engineers are studying the propulsion system. So there is a good amount of overlap there. But there are certain facilities which are like, at least in IIT Bombay, like exclusively aerospace people are doing, like aircraft design, like the wing design or the lift. So all those things are right now, but maybe they are also getting overlapped with other departments. Like, so they are primarily doing that. But there is a good amount of overlap. So like, let's say if we pick the wind tunnel facility, which is in aerospace, so you test a lot of these flying devices in wind tunnel facility. So again, both mechanical and aerospace people are doing it. So there is a good amount of overlap, but there is a good amount of independence in the aerospace departments also, where you get to learn about certain specific of aerospace related components and the design of those components.
Yeah.
The next question is, speaking of the interdisciplinary subjects, how much of an overlap exists between mechanical and computer engineering?
So, well, I mean, I am someone who works in combinatorics. I am not a traditional mechanical engineer, but, as like most problems here, in this day and age where resources are scarce, you do think about optimization as well, right? So I think at this point, the tools are available. If all the students here in mechanical engineering have courses in high performance computing, in optimization. And I think these tools are related if you want to work in any engineering field. As far as core computer science and engineering and mechanical engineering are concerned, they are at the core level, they are, different core subjects. So of course, you are not going to learn about operating systems if you're a mechanical engineering student. But this still doesn't stop you from taking courses in computer science and getting a minor in computer sciences at IIT Bombay. However, as far as your exposition to core computer science is concerned, it's going to be fairly algorithmic and not systems based.
The next question is, are NITs working on cryogenic system or big systems like this?
So actually, I'm not familiar with the infrastructure. So for the cryogenics, the infrastructure requirements are quite large. So let's say we take a nitrogen plant. So typically, so we would use liquid nitrogen cooling. By that, we could go down to roughly 80 Kelvin of temperature with the nitrogen. So what we do is like we take, let's say, our air, we suck the air, like pressurize it, separate the nitrogen from oxygen, we get the nitrogen, and through liquid helium, through the helium, like we extract the heat from the nitrogen gas so that it liquefies, and eventually it would liquefy around 78, 79 or 80 Kelvin, depending on the pressure. So the infrastructure requirement for these plants are, like for nitrogen plants, is not humongous, but it's, I would say it's still quite substantial. So I'm not quite familiar if NITs have these liquid nitrogen plant, but I'm assuming some of the NITs would definitely have liquid nitrogen plants and cryogenic engineering. And coming back to now, the another part of cryogenic, which is like more used in now going to even lower temperatures, like when I say temperature, like more less than 4 Kelvin or less than 1 Kelvin. So the liquid helium is used there, or a mixture of helium-3 and helium-4. So those plants are quite rare even in the country to date. The reason is helium is a very scarce and we have to recycle it again and again. So IIT Bombay is getting one such plant. It would be installed next year. But in, like, let's say we pick the Bombay region, Baba Atomic Research Center has, so very few facilities have this like very advanced cryogenic fields. And IIT Bombay is currently one of the leaders in the cryogenic area.
I request all the students to be very clear about the question so that we can translate the same things with the professors, and also try to be most inclined towards mechanical engineering so that you can get the best insight. So the next question, do students get time for research or it is included while studying?
So, yeah, I suppose even when we were students, I'll give you both perspectives. When I was a student, I worked with the Indian Statistical Institute at Delhi. I was working with the University of Chicago postdocs on building some game theory and econometrics tools. Several other things, so there are plenty of research exploration opportunities available here at IIT Bombay for students. Especially for mechanical engineering students, and this is apart from core research area. I mean, if you want to, let's say, just work on a Formula 1 racing car, or anything else that kind of excites you. I myself have been approached by second-year students, who want to work on research. So I'm fairly sure, you should take the first year to get yourself acclimatized in the system. And then from second year onwards, you can approach or, you can explore all the research sort of opportunities that are available to them. Most faculty members are very welcoming of undergraduate students trying to explore some research ideas. So yeah, I think the environment here is fairly accommodating. It's not that, and you will get some time to do research if and that's primarily based on your own motivation. Motivation is not something that someone can inject in you. That has to come from within. And if you're motivated, I think you can contribute in significant fashion.
And IIT Bombay, there are interdisciplinary centers also, like Artificial Intelligence and Machine Learning Center, then Koita Center of Digital Health. So there are Internet of Things like related to that center. Like, so there are many courses being offered by them, and students are free to take courses, do projects on them. So there are literally unlimited opportunities in every area. Like, you want to work on projects. And of course, individual faculty, again, from any department, you could contact. Let's say you are interested more in biology side of the project. Again, you could contact biology faculty and you could do still project with them, even if you are in mechanical engineering. So all the people here would be accommodating, and in fact, they would guide you through the process so that you are able to take good advantage of the system, like, and the openness of the system.
We have the Professor R. Rajkumar S. Pant, who himself is from Aerospace department and also want to answer the question regarding aerospace and mechanical engineering. So I request sir to answer.
See, I am going to actually address the students tomorrow at 10:20 a.m. on aerospace engineering. But this question which was asked is very interesting about mechanical engineering and aerospace engineering. So what I would like to simply say is that aerospace engineering is basically a daughter of mechanical engineering. What we do, our parent is actually mechanical and electrical. So we are an outcome of mechanical and electrical engineering. We are an applied branch. So the knowledge from various other branches are used to come up with more efficient and more optimized aerospace systems. So you can call it as a specialized branch of aerospace engineering. In many colleges, you have a degree of mechanical engineering with a specialization in aerospace in the end. That is what is followed in many universities. And even if you go to so many universities abroad, you will find they always have a department of mechanical and aerospace engineering. They don't have a separate department on aerospace only. I have taught 1 year as a visiting professor in NTU in Singapore. They have a department of mechanical and aerospace. I've taught for 1 year in a university called Virginia Tech in the US. They have a department of aerospace and ocean engineering. So it is aero, space and ocean. Okay. So more specific answers I would like to give tomorrow when I am addressing, because there are some people who are saying there are less jobs in aerospace, etc., etc. So I don't want to steal the thunder from the current speakers. I just wanted to butt in to say that those who are interested to know about aerospace engineering, please join tomorrow morning at 10:20 on the similar link. Okay, that's all I wanted to say. Thank you very much.
Thank you, Professor Pant. Actually, this is so useful because, I wish, this perspective that we have gotten after so many years sitting on the other side of the table, when we were students, we wish someone would have given us this perspective that at the end of the day, what you pursue, undergraduate is supposed to be a sort of a very broad exposure to several things. What you want to become. I mean, my spouse, she was an alumni from IIT Bombay. She was an engineering physics student, and she's now a faculty at TFR in mathematics. So it does, what you do at IIT is not going to define you. If you're passionate about mechanical engineering or aerospace or chemical engineering, you can do wonders. I mean, I believe the next, if you guys are so focused about how much, what kind of packages you will get, which I'm honestly telling you, when you come on this part of the table of 15 years from now, 20 years from now, this thinking will change. But the next billionaire is going to be a metallurgist. I mean, one who figures out how to harness, or how to make batteries that can recharge fast. What materials are going to come? I mean, so don't diss things just because computer science is fancy, or aerospace and chemical and mechanical are core things. It honestly depends on your passion, and you can do wonders if you want to become a good engineer.
In fact, going one step further, I think very soon a time will come when there will be no specialization at the undergraduate level. Exactly. You will be, even now we are thinking of, in aerospace department, we are thinking of aeromechanical, kind of a thing, thermal sciences. So I think students should not worry too much about branch specialization at undergraduate level. As you said very rightly, there are lots of opportunities, and you have to choose an institute that gives you flexibility.
Yeah.
That's more important than a very specialized thing.
True.
And there are many questions still about, like for example, Manasvi has a question about specialized degree in aerospace or energy versus general branch like mechanical. There are pros and cons of everything. So I think we will discuss about aerospace tomorrow in more detail when I address all of you. I'm actually working on the presentation right now. So wonderful. Very nice to see such enthusiastic students asking queries. And it's great. The Techfest team needs to be congratulated for this Ed-Conclave. Very nice initiative. Okay. I wish we had more of this and every year. Okay. So over to you, Sarvesh. Continue with your questions. I'm going to now.
Thank you so much, sir. So the next question we have is, what are the career prospects for mechanical engineering, in the sense that which are the largest employers for mechanical engineering graduates?
So actually, as we said, mechanical engineering is no longer restricted to core domains. So now, of course, people are going in the manufacturing, traditional fluid mechanics, thermal sciences, but a lot of people from IIT Bombay are going into medical sector. Like as we said, like gave examples of biomechanics, which is research is ongoing. People are going to, like, some people have opened their own companies in propulsion system. So where is another one of our faculty members with the students have opened, like they're trying to build space colonies. So like there is a ongoing startup. So they're working towards that. So climate modeling is another topic. One of our faculty is working on that. He is running his own startup also, like with students, like about this climate modeling. So the prospects are huge, like, and nowadays we, of course, like in the even the materials aspect, design perspective, we all cover machine learning, artificial intelligence also. So you get exposure of that areas as well. So it really depends where your interest click. It could be mechatronics, robotics, like traditional manufacturing field, thermal science, fluid mechanics, biomechanics, climate science, ocean engineering, maybe related to the optics, lasers. Like, so it really depends like where your expertise lie, or maybe due to just the EVs, the upcoming EVs, hydrogen vehicles, like, because people are working in such a diverse environment, so it's really hard to pinpoint like there, that's where the mechanical engineering student would go. It just depends on their interest, like what they're interested in learning and what kind of career they want to take it forward.
Yeah, I mean, I think, you know, as Professor Pant also highlighted, your undergraduate degree is going to be a broad overview of, a lot of things. And it's not a specialized degree like a master's degree or a doctoral degree, but it will prepare you for, so as he was also mentioning, someone has asked you, should you focus on college or branch? What are the prospects? These are genuine questions that come up when you aren't well standard. But don't let these, sort of predefined notions kind of clutter your mind with what is possible and what is not. You might be able to define something, completely new for that matter, like being a mechanical engineer, starting a different thing altogether. So don't restrict yourself with what is, what has been kind of a good. Definitely choose something that gives you that flexibility, as Professor Pant was saying, so that you can explore more. IIT system is such that, you come with a sort of your program defined. Unlike, some of the Western universities where you can come in and try to shop for courses and then decide your major. You come with your major decided. But the system is flexible enough that if you wish to pursue something else apart, in addition to your core subject, you can, and flourish in that as well. So, and a lot of students do that. A lot of current students are probably doing that. So yeah, there is honestly, what is possible is only restricted by, what your motivation levels are. So yeah, that's kind of what I feel about it. Any?
So we have the next question. What are the advantages and disadvantages of 5-year dual degree over 4-year B.Tech mechanical engineering?
No, I think the dual degree from this year onwards is no, it's not there. It's been sort of through JEE. You will not be offered a dual degree program. All the students will be, coming in as 4-year B.Tech students, and then at the end of 3rd year, you can decide to convert your 4-year B.Tech degree into a 5-year dual degree, where you leave the IIT system with a B.Tech in mechanical engineering and M.Tech in specialization. That could be computer manufacturing, that could be computer design. So those are, and through a dual degree, you will get to sort of the first 4 years are going to be exactly the same as your B.Tech curriculum, and then you will have to do a research based project which will become your master's project, and then you might have to do some additional courses as well which kind of work towards your specialization in that particular.
So we also had a question regarding job opportunities in mechanical, but I hope it is covered in the discussion until now. We'll move to the next question. What would you recommend to a student who was not able to get selected in a prestigious college like IIT? Where should he work hard so that he becomes a competent engineer?
So I guess it depends these days more on the motivation. So I could give a little bit of perspective on that. So nowadays, pretty much every course like on earth is available online. So learning has literally no limits. And in fact, as of now, let's say we want to learn new topics, we also learn online. If we have certain questions, we write to directly the people like who are delivering that course. He could be anywhere, she could be anywhere in the world. We write and then we could have a discussion if they are available. And generally, most of the people are available, so we are able to clarify our question. So there is no limit to the learning. Now coming to specific advantage of IITs, like what is over like a private college. So IITs have a large number of labs. So you get a lot of hands-on training component. So the course wise, you could learn pretty much online or your college, whatever college you get into. So IITs have that particular hands-on learning advantage. And that advantage, maybe some of the colleges like NITs, I think most of the NITs have also the lab component, but maybe some private colleges may not have that lab component. For that, you could do an internship or come for a research project. So there are semester-long research projects, there are internship in the summer, winter. So you could come to IIT Bombay or any other IITs, like where if you want to explore more hands-on component, then you could get that perspective. So at this stage, I would not say there is a disadvantage is going to any college because the learning has become so open to everyone. It doesn't matter like where you are, which college you are, but there are of course certain specific advantage of getting a hands-on training, which we at IIT are able to provide.
True, and I think in general, the most important thing when it comes to learning is your motivation to learn, and that kind of students in general should ask questions. It does not matter where you are, and satiating that curiosity is what takes paramount sort of importance. You should ask your professors or teachers whys and whats and hows. And if they are not able to address those questions, go try to address them yourselves. In fact, if you have a question about if you have a technical question about something and you try to email someone at IIT about it, I'm pretty sure I can at least talk about both of us. We would be happy to answer those questions. So, most of it is about satiating your curiosity. And as Dipanshu said, yeah, I mean, being IITs, we have labs where you get a lot of hands-on training as well. And sometimes, there is sort of less you can't really substitute that for much, but I think satiating your curiosity, no matter what someone tells you, is really important. Whether you are at IIT or you are at NIT or you are at any other engineering college, be curious, try to find answers to questions. That's how you learn.
So there's a common question which most of the students have. So, sir, I would like, the students want you to address the notion of prestigious institutes like IIT versus the rest of the institutes, and the extent till which this thing matters in terms of jobs and career opportunities.
So wait, I mean, you know what? Like, I think this is a question that requires a very, very long discussion and a change of perspective from. I mean, it's a person could say that it's much easier for us to talk about it. We could always say that, oh yeah, it doesn't matter. But hey, we were both IITians. We are also faculty member in IIT, and whatever we say. But I'll tell you a story, a particular story about one very good friend of mine. And I guess we can, at that point, possibly, because it's already 11:25, we can try to sort of wrap up the session. So I had a very good friend when we were, when I was, I wrote JEE in 2004. And at that time, we still had subjective, question papers and answers and whatnots. And this guy always used to be, sort of in the top 10 in the test series, and very, very smart guy, very, very, sort of motivated guy as well. But something happened, and since it's a one-day thing, that's the unfortunate part. But anyhow, he did not have a good day during, IIT. So JEE main. So well, at that time it was called screening and mains. You have now mains and advanced. That's a different thing, but mains was a subjective component. His screening rank was, I think, 56, all India rank, and his main rank was around 3,000 something. And at that time we were, IITs only used to admit up to 2,500 ranks, I think. We had only 7 IITs at that time. So it was very easy for him to get completely distraught, having been an overachiever all through, not being able to sort of, kind of just be true to his potential at that point. That could have, taken him completely down, but he decided to not let that sort of bother him. He went to, I'm forgetting which college he went to, but eventually he finished his engineering from there. Right now he's in New York working for Goldman Sachs. He's doing pretty well in his life. And so is the story of every person that I went to school with. So I don't think it matters much, but as I said, it depends a lot on what your ambitions are. Do you want to become a good engineer, or engineering is just a means to something which is a lot of money? I think then you should look elsewhere, because there are several other easier ways to make a lot of money. But if you're focused and if you have motivation to become a good engineer, I think you can do that with IIT or without IIT. There is little that will impact you. IITs do give you a good platform from where you can rise and get more opportunities, but there is, you might need to do a lot more hard work and be more persistent. But IITs are not make or break for sure. And I think Dipanshu will agree with most of that.
No, I think I completely agree with what Avinash said. Like, IITs are not the end of the world. And these days, the learning is so open, literally so open. Like we still learn, like we learn topic
Yeah.
every day, we learn online.
Yeah.
So all the things are available online. If we don't understand something, we just email the
Yeah.
person like and get it answered
Yeah.
or clarified. Like, so there is literally nothing stopping you. If you want to learn, there is nothing stopping you in any area, literally any area.
So the next question we have is, if students takes up a branch, say B.Tech in civil engineering in any IIT, and then wants to pursue master's or Ph.D in some other branch, so how feasible it is to pursue further studies in entirely different branch after pursuing B.Tech in different branch in IIT?
I mean, I mean, I know gazillion people who have done that. Like, you know,
Both of us have done that.
Yeah, both of us have done that. So, yeah, I mean, I was a undergraduate in mechanical engineering. I did my PhD in IUR. I know people who did their PhD in computer science, PhD in mathematics. So yeah, you know, nothing is hard coded through your undergraduate degree. So Sarvesh, at this point, I don't know how many more questions you want to take, but you know, we also have other engagements that we have committed to.
Yeah, sure, sir. There's just a last question. This is the last question. So how is computational mechanics course at IIT Delhi? How is it different from mechanical engineering?
Okay, yeah. So see, being a student, ideally, I can tell you that at IIT Delhi, mechanical engineering and applied mechanics departments, they're different. They're separate entities. So you get a computational mechanics degree there. At IIT Bombay, the two departments, basically you have everyone in one department. So it's not like, you know, you can't pursue computational mechanics if you come to IIT Bombay. You can always do research projects in computational fluid mechanics and, you know, basically get the same flavor of things. I think applied mechanics at IIT Delhi is specific to just the mechanics part of things. Yeah, I mean, our mechanical engineering. So again, as Professor Pant was saying, mechanics is a subset of mechanical engineering. But if you want to work, you know, specifically work in that specialization, then yeah, both those courses are good. You know, like I know some people at applied mechanics in IIT, and they're all very good at what they're doing.
Thank you so much, sir, for your time. This session has been enlightening, and I'm certain that students have also gained profound insights about the same.
I hope so.
So now I request all the students, we'll be back at 11:45. We'll have a 10 minutes break and move on to the next department. Thank you.
Thank you.
Thank you so much, sir.